Let us try to see mathematically labor supply model. Okay, labor supply model. Well, say utility function of any individual will be dependent upon consumption and leisure, consumption of goods and the leisure. So let me just write it for you guys here. C is consumption and L is leisure. So, well, and he tries to maximize this utility. Subject to what constraint? Remember this, that he has only, say, 24 hours with him. Okay, and that 24 hours he can spend in leisure or he can spend working. That's what it is. This is the time constraint. And the other constraint is basically that how much income he will derive. Say W is the wage rate per hour. Say for example, W is the wage rate per hour. Wage rate per hour. Okay. Now think about it. If he works for 1 hour, he'll get W. If he works for 2 hours, he'll get 2W. If he works for 3 hours, he get 3W, and so on. The full income which he can get is 24W. This is the full income. If he works for the entire day, then his income will increase to this 24W. Okay. And what is his consumption? Consumption is, say, C. Okay, this C which you have. This should be equal to, this is your expenditure. And say price of consumption is 1. Okay, price of consumption is, say, 1. Let me just write it somewhere. Price of consumption is, say, normalized to 1. So what is the expenditure? Expenditure is PC into C or 1 into C. So you can write this thing here should be equal to income. Income is 24W. So the two constraints which you have are subject to 24 equals to L plus capital L. That capital L is the amount of labor which you are supplying, and the other constraint is the income constraint, which is C equals to WL. And you know this, that this is the total expenditure, PC into C, but PC is equal to 1, so it is C equals to WL or 24W. Okay, that's your complete income, but we'll write it as W into L. That is because you don't know that you're going to work for 24 hours or not. Well, this is the income constraint which you have. Now, well, you guys, you can write this as, now in place of this L, from this first constraint you can write L as 24 minus small l. So it is 24 minus small l. Is that right? So you can simplify this to W into 24 minus WL, or C equals to 24W minus WL, or C plus WL equals to 24W. This is what you have. Okay, this is, let me write this equation again. C equals C plus WL equals to 24W. This is what you have. Now think about it. If leisure, this is small l is leisure. Okay. Now if L is equal to 0, then he would be consuming his full income, because in that case his C would be equals to 24W, because in case if he's not spending any time on leisure, he's spending his entire time on income. Sorry, he's spending his entire time on labor, so he can get his full income here. Well, in case if L is equal to 24, in that case he doesn't earn anything. And if he doesn't earn anything, it means that his income is 0, and in that case your C would come out to be 0. Fine. This W is basically the opportunity cost of leisure. opportunity cost of leisure, because in case if you are not spending 1 hour for fun, that is for leisure, you probably would be working. These are the only two uses of time which is allowed in this model. That is, either you'll work or you will have fun. So if you're not having fun, you will have to work. So in that case, W becomes the opportunity cost of leisure. Okay, this is small w. Fine. Now let's write the Lagrangian. Your Lagrangian is your L. This is script L. This is dependent upon C, L, and lambda. The objective function is, say, UCL plus, subject to this constraint, which is C plus WL equals 24W. You can write this as 24W minus C minus WL. What you will do is that you'll find out three partial derivatives, one with respect to C, other with respect to small l, another with respect to lambda. So what is LC? It is del U by del C minus lambda equals to 0. What is del L by del L? It is del U by del L minus W equals to 0. And what is del L by del lambda? It is 24W minus C minus WL equals to 0. This is what you have. Now these are equation 1, 2, and 3. So dividing second by 1, what you will be getting is del U by del L upon del U by del C would be equal to W. That is, marginal utility of leisure upon marginal utility of consumption is equal to W. So this is basically nothing but MRS, leisure for consumption, should be equal to W. This is the necessary condition. Okay, so to maximize utility, given the real wage rate W, individual has to choose to work that number of hours for which MRS of leisure for consumption is equal to the wage rate. Okay, remember this, that this is just the necessary condition. Okay, the condition which you have just drawn, this is just the necessary condition. Fine. And the condition would become a sufficient condition if MRS for LC, if MRS for LC is diminishing. That will indeed be the point of optima. Okay, so this is the simple labor supply model in which you are assuming that your time is divided between leisure and labor. There is a fixed amount of time which is available to you. Then in this model there is no non-labor income. Okay, as you could see, I've not this is the only labor income which you have. Okay, there is no non-labor income. It's not that you have any legacy or you have scholarships or you have some other pensions or whatever. Okay, so you don't have anything like that in this model. Probably in the next model we'll take care of the fact that you might also have non-labor income and how it will affect your choice.